Did two analysis at this point in chapter 3. Maximized our gate location and also our process settings that were needed for our part. Now we're going to take a look at a fill analysis. So we can come into our tab here and select our part fill analysis. Very simple. It's going to take a few minutes to run, but we simply select start. Now that our part fill analysis is complete, we can review the summary. The top of the summary dialog box indicates that the part can be filled easily, but part quality may be unacceptable. This information indicates that you should review the quality prediction plot, determine the magnitude of the quality problems, and check for whether the locations of these problems are critical to your part performance. We can look at some general information about our part. Again, understanding the materials and the environments that we're working in. Some other things we can look at inside of our design is the results that came up in our model browser. Our gate locations, our molding window, and our fill time, plastic flow, confidence of fill, quality prediction. By double clicking on any of these, we can truly see the different areas of analysis that we can utilize inside of our design. Air traps. Where do we need to vent our design or our tooling for this mold process? So a lot of information can be developed inside of this environment itself. So next, we can even have some functionality to help us examine these results. With examining these results and selecting the tool, we can get into our design and go into maybe a little bit more of quality prediction. With quality prediction, we can go through and set some standards inside of our design. Examine our part shrinkage. Again, just working with our standard tools inside of this environment, I can go to my head and select part shrinkage. Just like we've done in the past, I can go to my suggest menu and actually have Inventor run an analysis for me. Now that our summary has been completed with our shrinkage, we can review and take notes of the results. Some of the nominal dimensions, the shrinkage allowance, the mold cavity dimensions, estimated shrinkage, and the estimated dimensions. We're going to go ahead and click OK on the summary dialog box, and the shrinkage node will be created. In the mold design browser, we're going to right click the shrinkage and select Edit Feature. Notice the shrinkage percentage values are equal to the values obtained from the shrinkage simulation. The range of shrinkage values is only an indication of typical values in the database. It is not necessarily an acceptable value. Because these are based on processing conditions and part geometry, the simulation values could be slightly above or below these values. So from the Suggestion tab again, I'm going to rerun our analysis using our new shrinkage values. Now that our shrinkage analysis is done, review the results of the simulation. Notice at this time the nominal part dimensions and estimated dimensions are close. The mold cavity dimensions are now acceptable. I'm going to go ahead, select OK. Next we're going to go through and define the workpiece. So we can go to our Define Workpiece Settings dialog box. We're going to maintain it as rectangular, and we're going to edit the overall dimensions. As we go through and edit these dimensions, we will notice that our box is resizing itself at the same time. Also, if we select our More tab here, we can add in chamfers to the given corners. Simply hit OK when completed. Next, we're going to define the patching and the runoff surfaces. Again, working from left to right in our tool set, we're going to find our Create Patching Surfaces. Again, we'll let this analysis run. Once your patching surfaces are created, it's always a good idea to check your model to ensure that you have patches or surfaces where you'd like them. And also at the same time, you may find areas where you have patches created where you don't want them. So the easy way to go through and find these in our browser and delete them is simply put our cursor over the patch, and you'll see that its name will be displayed. Patch 1, Patch 2, Patch 4, and Patch 5. So I'll simply go up in my menu, select Patch 1, patch 2, 4, and 5 and delete them. With those out of my design, I can now select OK to have my surfaces formally created. Now, with my patching surfaces formally created, now I'm going to move to creating the runoff surfaces. Simple enough, simply select runoff surface and let Inventor do the work. Once our runoff surfaces are defined, again we can review them on the screen, and once acceptable, simply hit OK. With our runoff surfaces now created, we're going to move on and understand a little bit more about the parting diagnostic tool. So in this case, again, working from left to right, we'll find a parting diagnostic tool and simply select it. With our runoff surfaces successfully created, now we're going to look at our parting diagnostics tool. Again, working from left to right, we'll simply select our parting diagnostics tool to continue with our model. What we can see is some problems that initially come up inside of our diagnostics, some areas that we may want to look at and be cautious about. Once reviewing those, we can go ahead and go to our core and cavity faces. In this case, what we're going to see is a representation of our surfaces themselves. We can go through and use our slider at the bottom to really take a look and understand what our core and cavity faces will look like inside of our design. Once we're happy with the way things look and how our design is going to be achieved, we can simply select Done. In this case, now that we have our parting surfaces defined and we agree with them, we can generate our core and cavity. With our core and cavity generated, we can now save this file, and this ends Chapter 3.